Hey, Alex, you will not believe what I was just reading about quantum tech. It's felt so sci-fi, you know? But this is actually mind-blowing.
Heidi, I'm right there. For ages, quantum meant super cold, right? Huge, expensive cryogenic setups for delicate states. But that whole paradigm, it's really shifting now.
Totally. So, room temperature quantum, how big a deal is it that they're bypassing the extreme cold?
It's colossal. No complex, energy-hogging supercoolers means quantum tech is way more practical. Smaller, cheaper, super scalable. Imagine quantum components in everyday electronics. That's the big promise, Heidi.
So, what's making this happen? Any specific breakthrough for a room temperature quantum?
Oh, absolutely. A big one from Stanford. Material scientists engineered this tiny optical device that entangles photons and electrons at normal room temperature. They're using molybdenum diselenide, MOSE2, on silicon to generate twisted light. It stabilizes quantum states without supercooling. Pretty wild.
MOSE2. Wow. Twisted light sounds super cool. How does it stabilize quantum states without the extreme cold?
Well, twisted light isn't just regular light. It has orbital angular momentum, like a corkscrew. This property lets it interact with the MOSE2 material, locking in quantum states. It protects them from environmental interference at ambient temperatures. Clever engineering, you know?
That's genuinely amazing. So, what's the first big real-world impact from this room temperature capability?
Well, for quantum key distribution, QKD, it's huge. Exchanging unbreakable encryption keys was always hampered by cooling, but Toshiba Europe scientists transmitted quantum encryption keys over 158 miles using existing fiber optic cables at room temperature. No expensive cryogenic systems needed.
Wow, 158 miles at room temperature? That's huge for security. Could we see cities with quantum encrypted networks soon?
Absolutely, Heidi. Within a decade. This drastically reduces costs and complexity, making it feasible to integrate into existing networks for enhanced data security. Imagine knowing your data is truly unbreachable. Total game changer.
So, besides mind-blowing secure communication, what else could room temperature quantum tech enable? Like sensors or even computing?
Oh, absolutely. Beyond communication, these devices enable new sensors, precise quantum sensors for magnetic fields, electric fields, temperature. They operate under ambient conditions, huge for medical diagnostics, environmental monitoring, navigation, industrial tools. Super exciting for practical applications outside the lab, you know?
That sounds incredibly versatile. And what about quantum computing? Does this mean we'll have room temperature quantum computers tomorrow?
Not tomorrow for core processors, no. But it expands the ecosystem. It makes hybrid systems, room temp components with cryogenic processors, much more realistic. Also, maintaining quantum coherence in molecular qubits for over 100 nanoseconds at room temperature is a crucial step. It's not a replacement, but it builds a warmer foundation.